Okay, so there's going to be some noises in the background. Those are my kids and my dog and 100 other things going on. So I'm trying to record this. I'm going to try to make this into a 10-minute one. If I need to add, I'll add a second video. So doing the best I can here. So uh, let me talk a little bit about the idea of what it is that we do as researchers and why is it important to um, understand these statistics, understand what we're doing. And so I'm going to jump. I'm going to talk about the other things, but I'm going to focus on um, the one here on developing a research question and how to access secondary data analysis, because I think this will be a more significant part. And so remember in the other one, I was telling you about causal relationships. And so, in research, we're always asking questions about, you know, what is the universe around us like? Particularly when we talk about social scientists, it's about that social relationship. When it's about sociologists, it's specifically about society around us. Now, mind you, sociology is one of those fields that's very open and can take on a lot of different approaches. This means, you can bring a psychological point of view, a criminologist point of view. You can bring a someone who does economics, someone who does communication. You name it, you can bring it into sociology fairly easily, and it's why sociology perspectives tend to be so uh, common in all other fields. Like there's going to be a lot of stuff that you touch on in your sociology classes that you see are relatable to the work and classes that you might be taking in other disciplines. So the nature of this in understanding research, right, is that we study the world around us and try to understand it, and then we try to explain it using a scientific method, right? The methodology that we're dealing here is called quantitative methodology, which means that we take into account the number of times that things appear, that patterns appear, and then we assess, right, that pattern. We assess that pattern with what we describe as statistical analysis, right? The statistical analysis tells us that basically that the pattern that we are observing holds up to a particular standard. Well, what is the standard? Well, this is where we start doing more advanced work. Now, initially, I'm going to talk about the the basic statistics and what we describe as descriptive statistics, which is, is it that we talk about the observations that we're looking at, right? How do we describe them? The inferential statistics, which means what can we infer? What does this tell us about that pattern that we're observing? That's the part where we use more advanced techniques, and that's where we rely on what is known as probability. Probability gives us the opportunity to be able to, this is just general math, right? The notion of probability is just general math. And so what we're looking at is to see that the possibility of what we're observing, right, being not real. It sounds counterintuitive, but bear with me, that the possibility of the observance that we are making, right, what we are observing, that it is likely unreal is so small that it probably is real. That's a mouthful. And I know it's a mouthful, but you have to kind of understand that it does work kind of counterintuitively in our heads. But basically, that is what we're doing, is that we are with probability showing that our observations have a certain level of reliability of being right. And so I want you to think of it this way, because this is the standards that we're using, right? If someone told you that um, you have a race between two horses. Just as an example, this is ridiculous, but bear with me. If you have a race between two horses, and someone told you there is a 99% chance that this horse on the left is going to win. Now, you might ask yourself, well, how do you know that? How does you? Oh, because the horse on the right, has a limp, right? Or the horse on the right is injured, or the horse on the right can't race, right? So now, right, would you bet on the horse on the left? Yes, there's a 99% chance that the horse on the left is going to win. Now, is there an absolute chance? Absolutely not, right? You couldn't have an absolute chance. How can you not have an absolute chance? Well, the horse on the left can take 2 steps and fall and break its leg. The horse on the left can take 10 steps and fall over and die. The horse on the left can decide to start running around in circles while the lame horse makes its way around the track and makes it to the finish line. There's tons of possibilities, but the chances are, right, that's none of those things are going to happen, right? There's always a probability that those things will happen, but 99 is a really, 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 you know, almost absolute chance. And this is kind of similar to that, in that our observations, that the likelihood of them, based on the information we have in front of us now, right, that the likelihood that this information, that what we're observing is wrong, would only have a, 99% chance of being wrong, right? That means that we're probably very right, given the data that we have in front of us. So this is what we're doing with quantitative analysis, right? We're kind of showing these patterns and then putting these patterns up against the likelihood of them being wrong. That's what statistics does. Now, that's advanced statistics. That's inferential statistics. And that's what we do when we infer from our data sets. The first part of this class is focusing on describing the data set. Actually, the first part has been just kind of getting you to understand where the data set, that there is a data set, and what are we, and the notion of variables, and kind of introduce you to this language that we use in research. And how is it that we get to this point? So the first part was about talking about causal relationships. Well, what are causal relationships? Causal relationships is a cause and effect. When we're looking at information in front of us, right, we're trying to make sense of the universe in front of us. And so we know that if something happened, it's because something caused it. So we want to measure, how much of an effect, and is there an effect, and is that effect real? Now, there are a lot of ways in which we think about cause and effect. You can have multiple factors coming together and having an effect on something. That's usually the case in most of our statistics, right? In most of the research that we do, especially social research. So, for example, let's take something as simple as income. Well, what affects your income? Well, your education affects your income. We know that gender affects your income. We know that race affects your income. We also know that your parents' education affects your income. How do we know that? Even though that's much harder usually to collect data on. Well, we know that because other people have collected data on this and actually done research on it. But secondly, we also understand intuitively that there is, the ability of your parents being able to afford a better education for you, a better, whether it's because of the neighborhood they lived in or because of the colleges they were able to afford, that will have an effect on which colleges and schools you go to, which then has an effect on your overall income, right? You see that connection there? So there's all these things that create, have an effect on a variable like income. Now, those are causal relationships between variables, right? Variables are those characteristics, right, that are distinct between your subjects. In the next step, I'm going to talk a little bit about understanding the properties of the variables, right? We call them measurements. Each variable has a level of measurement. And so I'm going to spend a little time kind of talking about, at least 10 minutes, talking about level of measurements. Why? Because the level of measurement of the variable helps you to determine what type of statistic you can use on that variable. So, and then, of course, it then tells you what kind of statistic you would use to measure the relationship between those two variables. I know this is getting complicated, this is getting difficult, but I'm just trying to explain to you basically what it is that we are going to be moving towards. Each one of these, I will take time to go through it individually, and hopefully when I do that, it will not be as difficult to grasp. And then some of you might just get this right away and not have a problem with it, but I'm kind of using this based on the work that you've already done.